Thank you for joining us. In this video, we're going to be looking at the Module 3A test review for on-level pre-calculus and using, we're going to be doing the law of sines, going to be doing the law of cosines. We're going to be working with the area formula of 1/2 AB sine theta. And as well, we'll be working with vectors and we'll be working with navigation. All right. So a quick review. So important for whatever we have is that when you're given information and you're asked to solve the triangle, right, you need to figure out all sides, all angles. All right. So when you want to figure out all the sides, all the angles. And so what can help is initially if I'm given a triangle, right, we can look to draw our triangle, right? And we see that we have an angle of 21 degrees, and we have a side opposite angle of 170 degrees, and we can tell, right, that we have three angles in the triangle add up to be 90 degrees, so we know the angle A, and we can set up our ratio to figure out the side length. Now, some people prefer to, if we're looking for a side length, for example, if we're trying to find side length B, right, that we could be, say, B over the sine of 21 degrees is going to be equal to 170 all over the sine of 69 degrees. And if we solve, right, we would get our solution for B. And in a similar way, we can set up the ratio, and for most students, they feel better when they set up the values using the sine ratio, where the length that's unknown we can put in the numerator. So C over the sine of 90 degrees is equal to 170 all over the sine of 69 degrees, and we can get to our solution. Of course, there is a variety of ways, but the important thing is to understand what the setup is. All right, so for this particular one, what we had was angle, angle, side, and if I have angle, angle, side, it's going to be law of sines. Okay. For our next one, all right, we look at what our setup is. We have side length C is 26. All right, side length C is 26. We have angle B, we have angle C. And so once again, whether you want to call that side angle or angle side, right, doesn't matter. We know our setup is going to be using the law of sines. So we can see the setup in solving for our unknowns and using the sum of the three angles has to be 180 degrees, right? So we know that A plus B plus C, the angles is 180. All right. Look at the next example coming down here, just looking vertically. Right, so once again, if we look at the information that we're given, side A is 41, so there is 41. Right, we can figure out that this angle right in here is 32 degrees, because 32 degrees plus 28 degrees plus 120 degrees has to equal 180 degrees. All right, set up our sine ratio, and for this situation, we'll notice that that's angle, side angle, and with angle, side angle, you're still going to use the law of sines primarily. All right, look to our next one. All right, we have an angle of 84 degrees, side opposite 25, and we have B, so we see that this is a side angle or angle side, whichever one you want to think of. And in this situation, all right, we could be ambiguous, and this is important, is to understand that ambiguity is possible, but ambiguity is not required. All right, and here's how we can tell. So if we set this up and we find our first angle, right, and let's say that we find an angle of 36.6 degrees, right? So if this angle up here is 36.6 degrees, then our ambiguity would be possible if our obtuse angle was an angle that could set up. So if I say 180 degrees minus 36.6 degrees, that gives me 143.4 degrees. I will notice that it's impossible for this side length to be 143.4 because it has to be smaller than 84, right? Because 15 is smaller than 25, then that means we have no ambiguity, right? That the angle B has to be less than 84. So there's no ambiguity. Okay, continuing. If we look at our next situation, here is one that we do have angle side side or side angle angle, which once again, this is where we could be ambiguous. And if we look at this setup, right, we have 40 degrees, 19, and opposite B 20, and so we get B is 42.6, right? And 42.6 is more than 40, so we have to consider the possibility that I was obtuse, right? And I know that 180 degrees minus 42.6 degrees is 137.4 degrees, and so I have to consider, right? And in this case, I do have two possible triangles. I have the first triangle, but then I have the ambiguous case. And for setting up what our ambiguous case can look like, that's our setup that we could have, right? Angle with the acute angle here, right, and a given length. But we could have just as easily tilted that angle inside and had an obtuse angle. So we have to be aware of our two possible triangles. And if we look to the next one, right, we have a setup that looks to be angle side side once again. So we have 65 degrees and 10 and 20, right? And here we have no triangle possible because 10 is shorter than 20 and 65 degrees cannot be the smallest angle, right? But it would have to be um, smaller than 20, right? And that's going to be impossible. Here's another way that we could do it. We could say, hey, 20 sine of 65 degrees all over 10. If we make that computation of 20 sine 65 degrees all divided by 10, that gives us 1.8126, right? So therefore, it is not possible. And the reason being is that the sine of any angle must be, in this situation, right, but just in general, the sine of any angle must be between -1 and 1. I can't be greater than 1, right? But for our purposes, we're going to say, hey, that the sine within what we have has to be between 0 and 1, right? And we're not going to expect to have a 0. We're not going to expect to have a 1 because we'd have no triangle then. And in short, not possible with those ratios. All right, continuing. And if we look to here, right here, this is, if we look at our angle C, B, 12, right? So we have side angle side, and side angle side is going to be our law of cosines, right? And our law of cosines sets up in this form so we can solve, right? This particular one, side, side, side. If I have side, 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 right, here's my general setup. And this, once again, is also going to be the law of cosines. Okay, so we got the initial part of our review, looking at law of sines, law of cosines, a variety of examples. In the next video, we'll look at the next page of the review. Be sure you come back, ask questions as you need. Thank you for your time.